Welcome to an introduction to primitive data types. I'm going to start with an overview of object-oriented principles in order to show you the big picture. The information we manage in a Java program is either represented as primitive data or as objects. I've already introduced you to objects, so now let's get to know primitive data types. Programming languages like Java deal with many kinds of information: text, numbers, pictures, audio, video, and so on. Some of these are complex and change from time to time. No programming language can accommodate every type. Java's designers kept its basic type simple, so the language can stay as simple as possible. For the complex types like images, Java provides libraries or classes, rather than trying to make those data types part of the language itself. But every type in Java, no matter how complex, comes from a few basic types that are in the language itself. The building blocks of Java. So, what's a primitive data type? Well, it's a simple information format included in the Java language, and Java has 8 of them: byte, short, int, long, float, double, char, and boolean. You might hear programmers call these built-in data types or basic data types, but the formal term is primitive data types. Every other data type in Java has one or more primitive types as its basis. The primitive data types indicated in red will be used frequently in this course. Int, double, and boolean are all a part of the AP subset, and you will need to know them for the AP test. While char is not a part of the AP subset, we will work with it frequently. Literals. Java literals are syntactic representations or Boolean characters, numeric or string data. Literals provide a means of expressing specific values in a program. Let's start with numeric literals. Java has 2 basic kinds of numeric values: integers, which have no fractal part, and floating points, which do. The primitive type int is an integer data type, and double is a floating point data type. The numeric types are signed, meaning that both positive and negative values can be stored in them. Integers. Most whole number literals are of type int by default, and any whole number between negative 2,147,483,648 and 2,147,483,647. Floating point numbers, any number with a decimal point. They are treated as double values unless you add an F to make them a float. 1.2345 is a double literal. 1.2345F is a float literal, which is more precise than a double. Character literals. A character literal is a single character inside single quotation marks. For example, a lowercase a or an uppercase b, as long as they are within a single quote. Boolean. A Boolean value defined in Java using the reserved word Boolean has only 2 values: true and false. A Boolean variable usually tells us whether a condition is true, but it can also represent any situation that has 2 states, such as a light bulb being turned on or off. A Boolean value cannot be changed to any other type, nor can any other data type be changed to a Boolean value. The words true and false are called Boolean literals and cannot be used for anything else. Boolean values are named after Charles Boole, a 19th century mathematician who developed an algebra system of 2 values. Programmers often use this type in formal logic systems, where statements are either true or false. In Java, we use Boolean values in comparisons and in making decisions, such as asking the user if they have more input or if they'd like to play a game again. Using primitive data types. Here's some examples. Literal has a fixed value in Java. For example, 3.14 would be a double, lowercase a would be a char, or pancakes would be a string. Technically, string is an object, but it's used so frequently that we can classify it in with our primitive data types. A named value is a data field that is given a name. A variable, which is a value that that can change, or a constant, which has a value that is fixed and cannot change. String literals. Again, strings are not considered primitive data types because they are objects, but we can kind of group them with our primitive data types. So we see the first line, this is a character string, is in quotation marks. That means it is a string. String literals consist of double quote characters, 0 or more characters, followed by a terminating double quote character. So what does that mean, 0 characters? That means I could have an open quote and a closed quote and nothing in between, and it's still considered a character literal. Let's talk about the escape sequence. The escape sequence is a character preceded by a backslash, and it has special meaning to the compiler. We know that the question mark indicates the beginning and ending of string literals, but what if you needed an actual question mark in your string literal? We need a special way to print a quotation mark. And, well, as some of the other characters, like the backslash, that already has a special meaning in Java. The new line, double quote, and backslash escape sequence are not a part of the AP subset, but you should become familiar with them. So take a moment, pause the video if you need to, and study the escape sequences that you see on the screen. So here's some sample code just to show you how an escape sequence would work. So we have a little test program right there with our main method, and we're just simply going to print out a statement. She said hello to me. Well, we've got the word hello in quotes because that's what she is saying, and we actually want those quotes to print out. So if you look at the what's being printed there in code, you can see that we had to use the escape sequence in order to get the quotation marks around hello to print out. This is how the double quotation escape sequence is used in code and its corresponding output.